The final section of chapter 8, 8.6, solving rational equations. What is a rational equation? It's an equation that has fractions, right? And there's two ways of dealing with fractions when you have an equation. You don't have to copy this down. You could just listen. One option is to get rid of one fraction at a time by multiplying everything by the denominator of that fraction, or you could get rid of all fractions at the same time by multiplying everything by the LCD. Of course, I think it's easier to just get rid of one fraction at a time. But then again, if you're good with math, then you might want to think of the LCD and then multiply everything by the LCD. That'll get rid of all fractions at the same time. Let me explain, or let me show you an example of this equation. And I want to solve this equation by getting rid of one fraction at a time. Okay? So go ahead and tell me which one to get rid of first. It doesn't matter because we got to get rid of all three of them anyway. The 12. Okay, so we're going to get rid of the 12 by multiplying everything by 12 times 12 times 12, everything by 12, right? Now, of course, this 12 up here that you told me to multiply by will cancel with that one down there, and there's no more fraction. Beautiful, right? There's just a -1 left over. There's your equal sign. Now, what about the other ones? Right here, luckily, 12 is divisible by 4, right? So you could actually go 12 divided by 4 and get 3, and then 3 times 3 will be 9, and it'll be a 9x. Or if you wanted to, you could multiply 12 times 3. Like you could actually multiply the top. What's 12 times 3?
36.
And what is 36 divided by 4? 9. Either way, you're going to get a 9x. Right? Okay. And how about over here? 12, will it cancel with 8? No, but you could reduce, right? 12 over 8, you could reduce by 4, or you could multiply 1 times 12 and get 12, and you're still going to get 12 over 8, which you could still reduce by 4, and what do I get? 3 over 2, right? 12 divided by 4 is 3, 8 divided by 4 is 2, so you end up with a 3 over 2 on this side. So even though we just wanted to get rid of one fraction, we ended up luckily getting rid of two fractions, okay? We still have another fraction to get rid of, so what do I do? Multiply everything by what? By 2. Multiply by 2, multiply by 2, multiply by 2. Yeah, you multiply by the denominator of the fraction that you want to get rid of, and you got to multiply everything by the denominator of the fraction you want to get rid of. So of course the 2's cancel out. On the right side I'll have a nice beautiful 3. Over here, 1 times 2 is 2, has a minus sign in front. And 2 times 9 is 18 with an x. So you see, we got rid of one fraction at a time. We got lucky and two fractions canceled out when we multiplied everything by 12. But it's that easy. Cool. Now let's continue solving, even though the rest is easy. Plus 2, 18x equals 5. Divide by 18, divide by 18. X equals 5 over 18. But the real thing that I wanted to show is how I got rid of fractions by multiplying by the denominator of the fraction that I wanted to get rid of. Okay, so what if I took this same exact equation and I decided to get rid of all fractions at the same time by multiplying everything by the LCD? Well, first of all, you need to know what the LCD of 4, 12, and 8 is. It's actually 24. Okay, so if you're confused with LCDs, then don't even bother with this method, right? Just get rid of one fraction at a time. As you saw, it was pretty easy, right? But right here, if you think about like 4, 12, and 8, like, 4, I could change 4 to become a 12 by multiplying by 3, but 8 you can't change to a 12. So 12 times 2 is 24. 4 could be changed to 24, and 8 could be changed to 24. That's what the LCD is. If you multiply all three fractions by that LCD of 24, it'll get rid of all three fractions at the same time. You see, I could multiply 24 times 3 and then divide by 4, or I could divide 24 divided by 4 and get a 6, and then multiply the 6 times 3 and get an 18x. And then over here, I got a 24 divided by 12. That will become a 2. And of course, -1 times 2 is a -2. Equals, and over here, 24 divided by 8, that's a 3 up on top. And of course, 1 times 3 is a 3. Whoops. So To be honest with you, I kind of prefer, this is the faster way of doing it by multiplying everything by your LCD, but I kind of prefer just getting rid of one fraction at a time, But this is faster, so if you're good with the LCDs, then go for it. I'm not going to continue solving because you're going to get the same answer anyway. What was it, 5/18? Yeah. So let's actually, these were really easy because the denominators were simple numbers. Let's look at some where we have denominators that have a variable or a variable expression in them. So this is our homework for today and for tomorrow. We're doing numbers 1 and also 2 through 24 even, but we're going to skip 10 and 12. And this is all in Google Classroom. Don't think that you need to write this down right now. And then tomorrow, Tuesday, we're going to go back and cover solving rational inequalities. Like the ones that we're doing today, they're all equations. They all have equal signs. But tomorrow we're going to do some that have inequalities. It requires 2 more steps. So we'll wait till tomorrow to do inequalities. Today we're just focusing in on equations. And again, like I said, it's really easy to multiply everything by the denominator of the fraction that you want to get rid of, and just get rid of one at a time. Or if you wanted to, you could be like, oh, x, 4, and 2, the LCD is 4x, and multiply everything by 4x. And yes, it'll save you some time, but I think there might be more of a chance of you making a mistake, right? At least that's for me. That's the case for me. Sometimes when I try to multiply everything by the LCD, I make mistakes. So if you want to get rid of one at a time, which one would you like to get rid of first? It doesn't matter. The middle one? Okay. So multiplying by 4, multiplying by 4, multiplying by 4. Looking at the first fraction, that 4 will not cancel with the x, so I have to actually multiply top with the top. So I end up with 4 times 12, that is 48. It is still over x. It's still a fraction, of course. Now, the second fraction, the whole purpose of multiplying by 4 is to cancel out those 4s. So that disappears, and I end up with a nice, beautiful plus 3. No more fraction. And over here, luckily, it also works out beautifully. You could go 3 times 4, get 12, and 12 divided by 2 is 6. Or you could cancel, 4 divided by 2 is 2. 4 divided by 2 is 2, and 3 times 2 is 6. Many roads to the same place, right? So I still need to get rid of the other fraction, the one that has it over x, so I'm going to multiply everything by what? X. That's right. Times x here, times x there, times x there. This will cancel. You end up with a 48 plus 3x equals 6x. Now we have an equation with no more fractions. Let's get x by itself on one side. Subtract 3x. Subtract 3x. We're going to end up with 48 equaling 3x. Final step will be to get rid of that multiplication of 3 in front of the x, dividing by 3, dividing by 3. That'll give us our answer, x equals 16. Now, if you have enough time, you could plug in 16, reduce 12/16, add it to 3/4, and it should give you the answer 3/2. That's if you're bored, right? But if you're pretty confident in your work, then you could trust that that's the correct answer. One thing we do want to look out for is that when you plug in your number, you don't end up with 0 in the denominator. That would be undefined. And we'll get to one of those examples later. Right now, let's take a look at number 2. So this one looks a little easier because there's only 2 fractions, right? So the other ones had 3 fractions. There's only 2. Which fraction would you like to get rid of first? It doesn't matter. You're going to get rid of both anyway. So pick one. Okay, so let's get rid of that first fraction, this guy right here, by multiplying everything by what? X minus 1. The denominator, x minus 1. So I'm going to put x minus 1 right here. I'm going to put x minus 1 right here next to the negative 1. And I'm also going to put an x minus 1 over here. Multiply everything by the denominator of the fraction that you want to get rid of. Okay. So in this case, the first fraction cancels out. I end up with a nice, beautiful x. No more fraction. Yay. Okay. Now this is where it gets slightly confusing. Some people forget that the minus sign belongs to the 1. Okay. So that's actually like a negative 1 that you need to distribute into this binomial. So when you distribute the negative 1 into the binomial, negative 1 times x, that's a negative 1x. And then negative 1 times negative 1, that's actually a positive 1, equaling, and then over here, obviously the x minus 1 doesn't cancel with the 2, so I'm still going to have a fraction that has the 2 as a denominator, But up on top, I could actually distribute x times x, giving me an x squared, and x times negative 1, giving me a negative x. Are you with me? Okay. I could move on and get rid of this fraction by multiplying everything by 2, but you know what? I'm noticing this is an x, and that's take away x. That's easy. Might as well do that, right? X, take away x, what is that? Cancels out. So it's gone. So it's really an easy equation that has a 1 on this side and a fraction on that side. Okay, now let's get rid of the fraction on the right side. What do? Multiply by 2, right? You multiply by the denominator of the fraction you want to get rid of. And you got to multiply everything by the denominator of the fraction. So you got to multiply this 1 by 2. And of course, these guys canceled out, so you don't have to do anything else. So your new fraction is 2 on the left side equals, this canceled out, x squared minus x on the right side. Now we have a quadratic equation. And we should remember that whenever we have quadratic equations, you want to set it equal to 0. That way you could attempt to factor and split and solve with zero product property. Or if all else fails, you could have it set equal to 0 and use a quadratic formula, x equals negative b plus or minus square root of b squared minus 4c divided by 2a. So let's set it equal to 0. Subtract 2, cancels. Subtract 2, you can't really subtract it, so I'm just going to rewrite it. Here it is, x squared minus x minus 2. And instead of putting the equals 0 on this side, because 2 take away 2 is 0, I might as well put equals 0 on that side because it looks better for me. I prefer the equals 0 on the right side. Okay. So now we could focus in on this quadratic equation that's set equal to 0. And because it's a quadratic trinomial where my a value is 1, I am going to attempt to factor it, thinking what times what is my c value, that if you combine together is your b value. What times what is negative 2, that if you add together is negative 1. Negative 2 and positive 1, right? Equals 0. So now that we have a binomial times a binomial equals 0, that's where we could use a zero product property, or we could say if you have something times something equals 0, this first something could be 0, or the second something could be 0. So you're going to split them and set them each equal to 0. You're going to have an x minus 2 equals 0, x plus 1 equals 0. So solve both of them. You're going to get x equals 2. That's one answer. Subtract 1, x equals negative 1. That's your other answer. And we are done.
Oh, never mind. I got scared.
Yeah, it's not that bad. Now, once again, when you get your answers, don't just select those two answers and hit enter, because you need to take a second and make sure that you don't get 0 in the denominator. So for example, if this answer would have been a positive 1, I wouldn't include it as my answer, because the 1 take away 1 would be 0. That would make the whole thing undefined because you can't divide by 0. But in this case, it's a negative 1. And when you plug in a negative 1, it actually works out. Okay. Now you could plug in a negative 1 right there, and over here, do all that math, and it should give you a true statement. You could also plug in a 2 right there, and up here, do all that math, and it should give you a true statement. That's if you have a lot of time left over, right? Or if you're bored on a Saturday night. But right now, if you feel confident with the math that you did, these are your two answers. Just make sure that you don't end up with 0 in the denominator. You guys want to see another? Yes, please. Okay. How about that one? That one's fun. You know why it's fun? Because I underlined it. Okay, so I need to get rid of some fractions. What do? Multiply by what? S plus 2. Everything by s plus 2. That includes this s right here. I need to multiply it by s plus 2. And this fraction over here by s plus 2. And that works out great because both fractions have the s plus 2. So they're both going to cancel out. Look, cancels. Beautiful. What's left? A nice, beautiful s. Now, right here, this is a positive s that needs to be distributed to both. If this were a minus sign, that'd be very important to include the sign in front. If it were a minus sign, you'd have to distribute that minus s to both terms. But right here, it's positive s times s. Let me show my work here. Positive s times s, that's a positive s squared. Positive s times 2 is a positive 2s. equals, over here, s plus 2 cancels with s plus 2. What's left over? 5s plus 8. So we got rid of both fractions by multiplying everything by the denominator, s plus 2. Okay, we have a quadratic. We have s squared. So I know that when I have an s squared and other s's, I would like to set it equal to 0 so I could try to factor, split, and solve, or maybe use a quadratic formula. But in this case, I'm going to move everything to the left side, subtract 5s. Oh, wait a minute. Before subtracting 5s, I'm sorry. I just saw the left side. We could actually make this nicer by combining like terms. So this s and that 2s, that'll give us 3 s's, right? So we will have s squared plus 3 s's equals 5s plus 8. Okay, so now we're ready to move that 5 over. Subtract 5s, subtract 5s, and that will give us the quadratic equation s squared minus 2s equals 8. Subtract 8, and we'll have our quadratic trinomial equation set equal to 0. Oh, that's ugly. S squared minus 2s minus 8 equals 0. Are you with me? Now I factor. So a quadratic trinomial that has an a value of 1, always try to factor by putting that variable squared, put it right there and there, thinking what times what is a c value, that if you add together is a b value. So what is it? 2 and 4. Which one's positive, which one's negative? The 4 is negative, the 2 is positive. Okay. Now this is equal to 0, and the whole purpose of, it does matter because you got to think what times what is negative 8, that if you combine together is negative 2. So the negative 4 times 2 is negative 8, and negative 4 plus 2 is the negative 2. So yeah, it definitely matters. Now when you split it with zero product property, s plus 2 equals 0, s minus 4 equals 0. Yeah, it's going to take you back to the opposite signs when you solve. Take away 2, s equals negative 2. Plus 4, s equals positive 4. And if you write down both of those answers for this problem, you're going to get it wrong. Why is that? Because you got to take a moment and make sure that that negative 2, when you plug it back in, it doesn't give you 0 in the denominator. In this case, it does. That negative 2 right there, negative 2 plus 2 is 0. And we know that anything divided by 0 is undefined, right? So this cannot be part of our answer. That's what we call an extraneous solution. What does that mean? That's a extra answer that doesn't work. Okay, so the only answer for number 4 is s equals 4, because the 4 doesn't make it 0, the 4 doesn't make it 0. As a matter of fact, if you did plug in a 4 right there, down here, and up here, and did all that math, it will be a true statement. The only answer is s equals 4. Let's jump to, 20. That one looks challenging. So on any of these problems, what should you always do first before even doing any math? Before trying to simplify a fraction, before trying to add or subtract fractions, before trying to solve an equation with fractions, what should you always do first in this chapter? Starts with the F. Factor. So anything that's factorable, do it, right? So right here, this is factorable. There's v squared, the a value is 1, which means that hopefully you could factor, thinking what times what is c, that if you combine together is b. What times what is positive 2, that if I add together is negative 3? 1 and 2, right? But negative 1 and negative 2 is the right combo you want, because negative 1 times negative 2 is positive 2, and when you add these two together, it really does give you negative 3. Yay? So we have factored it. You could put a line through it because we already wrote it in factored form. But the bottom line is we are solving equations that have fractions. How? By getting rid of fractions. And how do you get rid of fractions? You multiply everything by the denominator of the fraction you want to get rid of. By factoring, it makes things a lot easier. Okay? Which one do you want to get rid of first? You want to go for this first one? Okay, so let's multiply everything by what? v minus 1, v minus 1, v minus 1. Everything by v minus 1. Okay? So the first fraction is going to disappear because they cancel out. I end up with a nice, beautiful 4v. Now the second fraction, it doesn't cancel. The v minus 1 will not cancel with the v minus 2. So I need to distribute the top with the top and keep it over v minus 2. You guys following me? So I really have a minus sign and then the fraction and then distribute the 5v times v, that's a 5v squared. 5v times negative 1, that's a negative 5v. And it is still over v minus 2. Now over here on the right side, luckily it ended up working out because the v minus 1, instead of distributing, notice that there's a v minus 1 down there, so we could cancel those out. And we end up with the nicer fraction 2 over v minus 2. So we have those two fractions left. I need to get rid of those two fractions by multiplying everything by what? V minus 2. Everything by v minus 2. So 4v times v minus 2. That blue numerator times v minus 2. And this 2 times v minus 2. Now, luckily, the v minus 2 and the v minus 2 cancel out. I end up with a nice, beautiful 2 left over on the right side. Luckily, the v minus 2 and the v minus 2 cancel out. And here's where it gets a little tricky. What is left over? Because you have a minus sign and there's a binomial, you must distribute the minus sign to both terms. It's just simple math, right? Because you have a minus sign, right? This says take away this whole thing. So I don't know, it might help you to put it in parentheses and distribute that minus sign to both. So distributing the minus sign, you're going to end up with a minus 5v squared. Let me write that down. Minus 5v squared. And distributing the minus sign right here, it's going to be a plus 5v. Plus 5v. And we still need to deal with this first 4v times v minus 2. So let's distribute there. 4v times v, that's a 4v squared. 4v times negative 2 is a negative 8v. So once again, we have a large quadratic equation. Let's make it look nicer by combining like terms, doing any math possible. We could combine the 4v squared, take away 5v squared. What is that? Negative 1v squared. Thank you so much. And we could also combine the negative 8v with the plus 5v, giving us negative 3v. And we have the equals 2. Now we could move both of these guys over to this side, making them both positive by adding a v squared and adding a 3v, and then having the plus 2 at the end. Or we could move the 2 over, but then we're going to have to change all the signs by dividing everything by negative 1 to set it equal to 0. I don't know. Should we move it to the right or to the left?
To the right. To the right.
To the right? Okay, so let's move everything to the right. I'm going to add 1v squared. That'll cancel it out. Add a v squared. So I'll have so far v squared plus 2 equals a negative 3v. And then I'm going to add 3v, add 3v, and I'll end up with 0 equaling v squared plus 3v plus 2. So now we have a quadratic trinomial equation. I'll rewrite it up here. V squared plus 3v plus 2 equals 0. I'm going to factor, split, and solve. So put the v there and the v there. What times what is 2 that if you add together is 3? Plus 2 and plus 1, yeah. Plus 2 plus 1, or plus 1 plus 2. All right, so when we split it, v plus 2 equals 0, v plus 1 equals 0. You're going to get two answers. V equals negative 2, and v equals negative 1. So maybe those are our two answers. All we got to do is double check and make sure that we don't end up with 0 in the denominator. So when I plug in a negative 1 and negative 1, that's negative 2. That's cool. When I plug in a negative 2 right there, negative 2 and negative 2 is negative 4. We're fine. And if we were to plug them in here, we're not going to get 0. Plug them in there, you're not going to get 0. So I'm pretty confident that these are the correct answers.
So it goes not to this, right?
So once again, guys, the answers, the answers are on Google Classroom, the assignments on Google Classroom. Today, I want you to do the even ones and the equations, and tomorrow we'll be working on the inequalities.